All right, sphingomyelins are a class of phospholipids, and we introduced that in the last podcast. So now we're going to talk specifically about this second class of phospholipid. All right, so we've already talked about this slide on our last podcast, but I wanted to refresh your memory on the structural differences between triacylglycerols and phospholipids, and then we're going to look at phosphoacylglycerols versus sphingomyelins. So again, all phospholipids have an alcohol, an amino alcohol. It's either going to be choline or ethanolamine, so it's a lecithin or a cephalin. They're going to have that phosphodiester bond, and they're going to have at least one fatty acid. Now, phosphacylglycerols, structurally, these guys are a little different. They have that glycerol backbone, and they have a second fatty acid. Sphingomyelins are going to be a little different. Their backbone is made of sphingosine, and they only have one fatty acid. And so on the next slide, we'll look at structurally with the actual structure of them, what to look for when trying to see the difference between phosphacylglycerols and sphingomyelins. All right, let's go through some basic characteristics of sphingomyelins. They don't have a glycerol backbone. You saw that on the last slide. That's what makes them different from phosphacylglycerols and from triacylglycerols. They have a backbone that's made out of sphingosine, and it doesn't have an ester bond in it. They have a fatty acid that's directly bonded to the sphingosine backbone by an amide bond. This guy is going to be how we distinguish without a doubt that you have a sphingomyelin versus a phosphoacylglycerol. These words are tough for me today. We find sphingomyelins in brain and nerve tissue. You might have heard of the myelin sheath, which is made of sphingomyelins. That's the coating in nerve cells that's important for nerve transmission. We'll talk about that as well on a future slide. All right, we saw the general structure of the sphingomyelin on a previous slide. It has a sphingosine backbone. This fatty acid is connected by an amide bond, so we'd expect to see an amide somewhere right in here connecting to our fatty acid rather than an ester bond, and that's going to be your telltale that you have it if you're not able to recognize a sphingosine backbone. All right, so looking at the structure, we went ahead and did a skeletal structure here. We have our fatty acid. We have an amide bond, which I like pointing out that you have a nitrogen right next to your sphingosine. You don't see an amide bond in anything else. That's a good telltale. You have your phosphate group in the is a phosphodiester bond, and you have your alcohol. This again can be lecithin, or it can be cephalin. What's important to note is you have a very long hydrocarbon region, and those are going to have all nonpolar bonds. You're going to have a large nonpolar region, but because you're phosphodiester bond and the alcohol you have, you are also going to have a polar head. So this is similar. Oh, that was terrible handwriting. I'm so sorry. You're going to have a polar head and a nonpolar tail as well, but you're only going to have one of those long nonpolar tails, unlike a phosphoacylglycerol that has two, or a triacylglycerol that has three long tails. All right, so looking at an actual structure, I am going to identify right here is my sphingosine backbone. Notice that we don't have any ester bonds in there. There's no ester holding one chain to the other. Here is my amide bond. Okay, having that amide bond coming off the second carbon down of your sphingosine backbone should be a telltale. There's my nonpolar tail. I have a different color, my phosphodiester bond, and then I have my alcohol group, my amino alcohol. In this case, this is choline. So if I were to give you these structures on a test, I would expect you to be able to, based on a structure similar to this, identify is this a triacylglycerol, a phosphacylglycerol, or a sphingomyelin. So as we've mentioned before, the coating that's going to surround and insulate your nerve cells is particularly rich in sphingomyelins. It's the myelin sheath. If the myelin sheath starts to break down in your body, which we do see in multiple sclerosis, it's going to lead to disabling neurological disorders. MS is a degenerative disease, and it's characterized by the scarring of the myelin sheath. So the myelin sheath is this surrounding layer, and you guys have taken or are close to taking anatomy and physiology, and you guys are going to go into way more depth on this. But those are primarily made up of sphingomyelins. If you don't have that protective myelin sheath, your normal nerve transmission is going to be disrupted, and you're going to wind up with a variety of different symptoms as a result of that. Like any other neurological disorder, you're probably going to have numbness and blindness, as well as speech disorders and tremors. Those would be characterized by any neurological disorder. All right, I am just including this because I think your book does a bang-up job of comparing the differences between triacylglycerols, phosphosylglycerols, and sphingomyelins. I'm not going to go through all of this, but figure 19.5 in your book is spectacular in comparing and contrasting them so that you can start to get the hang of identifying those structures based on either their condensed structural formulas or their skeletal structural formulas.